Hello, sixth period, and happy Wednesday. We have a couple things that we're going to do as we get started. You should make sure you have out that molar ratios homework. Now, clearly I'm not here to check it off, which means you need to check and see if you uploaded that to my ADUB, right? You can submit that online, and that's how I'll be checking that off. I'm in Germany right now, a science team, so I hope that you are all kind to the people that are popping in and out of class, but that you're still productive the next few days, okay? So we're going to start today off with a warm-up. Here's our warm-up that you should be doing in your notebook. If I have 243 buns, 500 patties, 200 slices of cheese, and 20 strips of bacon, how many double cheeseburgers can I make? Our recipe is below, right? Each recipe takes 1 bun, 2 hamburger patties, 3 slices of cheese, and 4 pieces of bacon to make that double bacon cheeseburger. So what I want you to do is figure out how many can I make, why, and how did you figure that out? Then you're going to think about what is our limiting ingredient in the recipe, what's holding me back from making more, and what's happening to the other things. So go ahead, pause the video, take a couple minutes to think about this, and then we'll come back and talk about it. Okay, so hopefully you realized that I can only make 5 double bacon cheeseburgers because this 20 strips of bacon is what is holding me back here, right? Everything else, I have a lot of it. I could make 243 cheeseburgers if we're just talking about buns. I could make 250 cheeseburgers if we're just talking about patties. Right, like I can make a lot of cheeseburgers, but my bacon's really holding me back here. So the limiting ingredient to my recipe is my bacon. All the other stuff, it's just leftovers, right? I can use that later on. But this is what we're going to be thinking about today, is leftovers in chemical reactions, okay? So if you haven't uploaded that molar ratios homework, do that now. We did our warm-up. We're going to review that homework. And then you're doing a simulation lab today online. Your goal by the end of the day is that you can convert between grams, moles, and particles of 2 different chemicals. You can identify a molar ratio using a balanced chemical equation. You can identify the limiting and excess reactants, and you can determine how much product can be produced given multiple values, just like we did with our cheeseburgers. Okay, so what we're gonna do is we are gonna stop sharing that screen, and we're going to share molar ratios. Okay, so let's review that homework. Molar ratios. We did number 1 together in class, right? So let's take a look at number 2. First, you got to balance that. This is a 1, 1, 2, 1. And then we're converting moles to moles, right? Using that molar ratio. So 1 mole on the bottom, 2 moles on the top, multiply across the top, divide by what's on the bottom, and you should get 1.67 moles of hydrochloric acid. In number 3, exact same thing, just a moles to moles, right, with a 3, 1, 2, and you should get 0.45 moles of hydrogen. In number 4, right, still make sure this one's already balanced for you, which is really nice, but we're going now all the way to grams, right? We're trying to figure out how many grams. So you go moles to moles, then moles to grams. This is your molar mass from the periodic table, right? Don't forget about that. And now we have 0.0099 grams of hydrogen. If we go to the next page, right, this is a 2-2-1, where we can turn our grams to moles and then moles to moles to find that we have 0.606 moles of iron. With number 6, we're going to use Avogadro's number because we start with molecules. So we take 1.82 times 10 to the 23rd molecules. We use Avogadro's number to convert that to moles, and then we can go moles to moles to find that we get 0.101 moles of propane. The last one, you have to do a big, this is 3 whole steps. You're going to go grams to moles, moles to moles, moles to grams. You need 2 molar masses here, and you should find that you get 164.5 grams of iron, okay? Hopefully you know if you have questions already because these answers were on the back of your homework assignment, and you should be feeling pretty good at this point. Okay, so what we're going to do with the rest of class is I'm going to give you a little introduction to what's going on with our limiting reactant simulation. So up front, you will be able to find this limiting reactant PhET lab, right? Simulation lab. This is exploration. We're going to be debriefing this whole thing next class. And by next class, I mean the magical me in your computer, right? You're going to be working with a partner in your lab group, right? So find someone that you want to work with. It can be someone that you normally work with or someone that you don't. But follow the link at the top of the page, or just like type in limiting reactant PhET and it will pop up on Google, right? Sometimes that's easier than typing in a full hyperlink. And you can't ask me if you get stuck, but there are a lot of people that you can't ask. If you need to send me an email, feel free to. If you want to ask any other teachers, you can ask Mr. Sidman, you can ask Ms. Mingles, you can ask Ms. Johnson, right? There are lots of people available to you to ask that can help you with this, okay? But peers are your number one resource today, and exploration, so we should be okay walking through this. This does have to get uploaded to my ADub, right? This is how I'm going to be checking off that you're completing things while I'm gone, so please make sure that you keep track of that. Otherwise, keep up the good work. Send me any emails if there's any major concerns, and I'll see you guys when I get back. Bye.